Now let's go over a sample problem called symmetric tree. In this problem, we're given a binary tree and we want to check whether it is symmetric. For a binary tree to be symmetric, it means that the half of the tree is a mirror of the other half. To look at some examples, in the first example on the left, we consider this to be a symmetric binary tree because at every level, the half of the tree is a mirror of the other half of the tree. In the second example in the middle, this is not a symmetric tree because as you can see, in the bottom level, the number 3 is not a mirror reflection of this number 5. Lastly, in the third example on the right, this is also not a symmetric tree because in the bottom level, because this number of 4 is not mirrored by this value of 3. So now we ask ourselves, how can we look at this recursively? First, when we are giving a binary tree, we ask, is this tree symmetric? We can break down that question into, is the right subtree a mirror of the left subtree? Then we can further break down that question into, well, is the right subtree a mirror of the left subtree? And is its right subtree a mirror of its left subtree? Now let's think about what are the conditions that should be true for a tree to be symmetric. And let's also think about what should our base case be here. For the condition that should be true for a tree to be mirror images, first, the root node values must be the same. Second, left subtree of the left tree and right subtree of the right tree should be mirror images of themselves. Similarly, the right subtree of the left tree and the left subtree of the right tree also have to be mirror images. For a base case, it is reached when we also reach the end of the tree and we can no longer further recursively go down this tree. Now, let's take a look at the code implementation. First, we have this isMirror function that takes in two roots in which we call root 1 and root 2. Now, for its logic, if we have a base case, then we want to return true because we can no longer further recursively go down this tree. Otherwise, if root 1 is not none and root 2 is not none, then we want to check its symmetry. And if it's symmetric, then we want to recursively call this function. Lastly, if neither of these conditions meet, then we know that we have an unsymmetric tree and we return false. All of this isMirror function is wrapped around this parent function called isSymmetric. IsSymmetric takes in a single parameter of root and calls this isMirror function with its root passed to it to this function. Now that we have taken a look at a high-level code solution, let's fill out some of the details. For the part that we want to check symmetry, this is fairly straightforward. What we had to do is we had to check if the value from root 1 is equal to the value from root 2. If that's the case, then we call the recursive function again. Otherwise, we do nothing, and eventually this function will return false to say that this tree is not symmetric. Then we'll look at how we will call the recursive function. Remember, what we want to check is to see if the left subtree of the left tree is equal to the right subtree of the right tree, and we want to check if the right subtree of the left tree is equal to the left subtree of the right tree. This can be represented by this recursive call. First, we have a recursive call that passes in the left subtree of the left tree and the right subtree of the right tree. And then we have a second recursive call that passes in the right subtree of the left tree and the left subtree of the right tree. And you see that these two recursive functions are also combined by this AND operator. So for this tree to be symmetric, these conditions have to be true all the way throughout the tree. And that's it. That is the entire solution. As you can see, it can be quite challenging to figure out how to do the checks and how to call the recursive calls with different set of parameters. However, once you have the high-level structure of the solution, you can see the recursive solution can be elegant and also concise.